All right, today we're going to talk about the distance formula. D equals the square root of x2 minus x1 quantities squared plus y2 minus y1 quantities squared. Now this formula is in your EOC reference sheet. So when you're taking the EOC test for geometry, you have this available to you. Okay, now it's important to note that these x2, y2, and x1, y1 points are arbitrary. You can choose any point to be your x1, y1, and x2, y2, but you must be consistent when you put the values in. And let me show you what I'm talking about. So we draw our Cartesian plane. 1, 2, 3, 1, 2. Let's say this is our first point. Remember, the x value comes first, 3, 2. Okay, let's put our second point in the third quadrant. So we're going to go over here, minus 1, minus 2, minus 3, minus 4. And let's say minus 1, minus 2, minus 3, minus 4, minus 5. Let's say we're over here. Okay, so we're at minus 4, minus 5. Okay, so we want to find the distance between these 2 points. Remember, the distance between any 2 points, the shortest distance is a straight line, right? So it's actually line segment between these 2 points. Okay, so we want to calculate this distance, d, right? Okay, but in order to do that, we're going to use the Pythagorean theorem, right? A squared plus b squared equals c squared. So we're going to create a right triangle, right? Okay. So this distance formula comes from the Pythagorean theorem. This leg right here is your a, right? And then this is your b. A squared plus b squared equals c squared, right? So when you try to find c, or in this case, what we're saying is the distance formula, this distance here. If you're trying to find the hypotenuse, right, you have to take the square root of both sides of that. Let me show you what I'm talking about. A squared plus b squared equals c squared, right? We want to find what that c is, right? If this is our c, right? I know it's labeled as d, but that's for the distance formula. We'll get back to that, okay? So we need to take the square root of both sides, square root of c squared, and square root of a squared plus b squared, right? Which these would be our a and b, right? So we're squaring the dimensions of the legs, right? But what are the dimensions of the legs? The dimensions of the legs, and that would be equal to c, right? That's going to be our distance. So the square root of a squared plus b squared, right? But this looks very similar to this, right? The a here is our difference in x values, right? What does the difference mean? That means subtract. Subtract the x values, right? Horizontal. So the horizontal value here at this point is the same thing as the horizontal value here at this point. So -4 here, right? So the difference between -4 and 3, right? And then for this leg, we're talking about the difference between -5 and +2. This difference here, right? Because +2 is the same height here, the same y value. Okay, so I'm going to erase this little rabbit trail, and we're going to go back over here, and we're going to do d equals the square root of, and this is where it's important to be careful when you put your values in. Let's say that we chose this to be our x1, y1. This is our x2, y2. Okay, I chose that order specifically so that you can see the error that most students make. When we put these values in, let's put them in. Our x2 is 3, right? So we're just plugging in the values into the formula. So we put 3 here, right? Minus, what's our x1? Well, our x1 is a -4. And we always want to put the negative values, I tell my students, in their own parentheses, -4, right? In its own parentheses to help keep you from making little mistakes here with the signs, right? Then you close that first parentheses, make sure you don't forget to square that quantity, and then plus our y2, which is x2 minus our y1, which is negative 5. Negative 5, right? And then don't forget to close that second parentheses here and square it. Okay, now we go down one more. Distance equals the square root. Okay, don't forget, whenever you subtract a negative, that's the same thing as saying add the opposite, plus positive. I want you to change that on your problem. Change it in there. Because if you don't make that change, you're going to make an error, right? Now we have 3 plus positive 4. 3 plus 4 is 7. So we have 7. Don't forget the quantity squared, right? Plus 2 plus 5 is 7. Quantity squared, right? Okay, so now let's go to the next line down. Distance equals the square root. What's 7 squared? Well, that's 49, right? 49 plus 49. Okay, so we have distance equals the square root of 98, right? So let's break down 98 because there will be problems on the tests, the standardized test that wants you to present your answer in simplified radical form, right? So we're going to simplify the square root of 98. So we're going to break down 98 into its prime factors, right? So 98, whenever you have an even number, let's just divide by 2, right? You take 2 out, right? You take 2 out, and then you have 49, right? Now, 49 you can break down, right? That's 7 times 7. So now we have prime factors, right? So once you've broken it down into its prime factors, you can look at all the doubles, right? We have 2 7s, and we can take those out of the parenthesis, of the square root. So we have distance equals 7 times the square root of what remains. Well, after you take these out, you have 2. 7 root 2, right? But you'll notice that the difference between our x values and the difference between our y values is the same, and they're both 7, right? This is a length of 7, and this is a length of 7. So what type of triangle is this? It's an isosceles triangle, right? Isosceles triangle. Isosceles triangle, right? So this is listed on the EOC reference sheet as one of your special triangles. This is the 45, 45, 90 triangle. These two angles at the base are congruent, and they're 45 degrees, right? 45 degrees. And what's special about the isosceles triangle is that the isosceles right triangle is that the distance here of the hypotenuse is equal to square root of 2 times one of the legs, 7. Okay, now for the EOC test, you are allowed to use the FAST calculator. So I'm going to attach to this video how you would input these values into the FAST calculator so that you don't have to make any mistakes in arithmetic here, and you can go straight to the decimal answer and then put it in. All right, so here we are at this calculator, Desmos for assessment. This is going to be similar to the FAST calculator you have access to for the EOC test. And we're going to use the same points we had before. So we're going to start with the distance is the square root, right, of our quantity of x2, which was 3, minus our x1, which, remember, put its own parentheses for the negative numbers, negative 4. Okay, end that parentheses for the negative number, and then end the parentheses for the entire difference of the x's. And then don't forget to square it, plus start a new parentheses for our y2, and our y2 was 2, minus its own parentheses for the y1, which is negative 5. Okay, and then we end the second quantity. I like how it fills it in for you so that you don't mess it up. And then don't forget quantity squared. And so we got 9.8 89949. Now, the EOC test should accept this decimal answer, but you can see if I clear and we just do 7 times the square root of 2, we have the same exact answer, right? So I prefer simplifying the radical, but if you prefer to just put it in, you have the formula available to you on the EOC reference sheet. So practice with this so that you will do well on the test. I'm going to post more content for geometry and hopefully algebra 2 as well coming up. So like and subscribe for more.